You probably learned about different atomic models in high school. At first, atoms were thought to be tiny, indivisible spheres. Then came J.J. Thomson's plum pudding model, where electrons were scattered within a positively charged cloud. But this idea crumbled when Ernest Rutherford's gold foil experiment revealed a dense, central nucleus. Yet, a mystery remained: how did electrons move around this nucleus? That's where Niels Bohr entered the picture. His groundbreaking atomic model didn't just refine our understanding of the atom, it transformed the very foundations of modern physics. Niels Henrik David Bohr was born on October 7, 1885, in Copenhagen, Denmark. He grew up in an intellectually stimulating environment. His father, Christian Bohr, was a renowned professor of physiology. His mother, Ellen Adler Bohr, came from a distinguished Jewish banking family. This combination of scientific inquiry and cultural richness played a crucial role in shaping Bohr's future. Bohr had two siblings, including his younger brother, Harold Bohr, who became a famous mathematician and an Olympic soccer player. The Bohr household was filled with intellectual discussions, nurturing Niels' love for science from an early age. Bohr showed an early aptitude for science and mathematics. He attended the University of Copenhagen, where he excelled in physics. His early research was on the surface tension of liquids, but he soon became fascinated with atomic structure. His deep interest in theoretical physics led him to pursue his doctoral studies under Christian Christensen, Denmark's leading physicist at the time. In 1912, Bohr married Marguerite Norland. She became his lifelong partner and key supporter of his work. Marguerite played an essential role in helping Bohr organize his thoughts and communicate complex scientific ideas. The couple had 6 sons, though 2 of them tragically died young. One of their sons, Bohr, followed in his father's footsteps and became a renowned physicist. He won the Nobel Prize in Physics in 1975. After earning his PhD in 1911, Bohr traveled to England. He worked with J.J. Thomson at Cambridge. However, it was his time with Ernest Rutherford at the University of Manchester that changed his career forever. Rutherford's experiments had revealed that atoms had a tiny, dense nucleus surrounded by electrons. But the existing models couldn't explain why electrons didn't collapse into the nucleus due to electrostatic attraction. Bohr proposed a revolutionary idea. Electrons could only occupy certain energy levels or orbits around the nucleus. They could jump between these orbits by absorbing or emitting energy in discrete packets, or quanta. This concept introduced the idea of quantization in atomic physics. It provided the first working model that explained atomic spectra. Published in 1913, the Bohr model was groundbreaking. It later became a cornerstone of quantum mechanics. In recognition of his contributions, Bohr was awarded the Nobel Prize in Physics in 1922. Bohr's work on atomic structure laid the foundation for quantum mechanics. But his influence didn't stop there. He played a key role in developing the Copenhagen Interpretation. This became one of the most widely accepted interpretations of quantum mechanics. According to this interpretation, particles don't have definite properties until they are observed. This idea was at odds with classical physics and sparked intense debates with Albert Einstein. Einstein believed in an objective reality independent of observation. He famously remarked, "God does not play dice with the universe." Bohr's response was equally famous: "Einstein, stop telling God what to do." One of the most notable debates between Bohr and Einstein centered around the EPR paradox. Proposed by Einstein and his colleagues in 1935, the paradox suggested that if quantum mechanics were correct, 2 entangled particles could instantaneously affect each other across vast distances. Einstein dismissed this as spooky action at a distance. However, Bohr argued that quantum mechanics was complete. He believed entanglement demonstrated a fundamental truth about reality. We previously made a full video on the Einstein versus Bohr debates, be sure to check it out. As World War II intensified, Bohr found himself in a precarious position. Although he was not Jewish, his mother's Jewish heritage made him a target of Nazi persecution. In 1943, he was forced to flee Denmark, escaping to Sweden and eventually making his way to Britain. In Britain and later the United States, Bohr contributed to the Manhattan Project. This was the secret U.S. initiative to develop the atomic bomb. However, he was deeply troubled by the destructive potential of nuclear weapons. He advocated for international cooperation and the peaceful use of atomic energy. Bohr warned world leaders about the dangers of a nuclear arms race. After the war, Bohr returned to Denmark and continued his research. He played a significant role in the establishment of the European Organization for Nuclear Research, CERN. He remained an advocate for scientific collaboration. He also helped found the Niels Bohr Institute in Copenhagen. It became a hub for quantum research. Many leading physicists of the 20th century studied and worked at the institute. This further cemented Bohr's legacy as both a scientist and mentor. Bohr remained active in scientific and political discussions until his death. On November 18, 1962, he passed away in Copenhagen at the age of 77. He was buried at the Assistens Cemetery, a resting place for many great Danish thinkers. His contributions earned him numerous honors, including the Order of the Elephant, Denmark's highest civilian award. His face even appeared on Danish banknotes, symbolizing his status as one of Denmark's most important figures. Even after his passing, Bohr's influence persists. His debates with Einstein continue to shape discussions on quantum mechanics. His work remains a fundamental part of physics education worldwide.